Hello, I'm Andres Nadal and I'm going to present to you Euler's number with my classmates Stefan and Chavez and Abraham Sarasarus. Euler's number is an irrational number and a transcendental number. Irrational means that its decimal places will never end, meaning that it is actually impossible to calculate. It is calculated, well, in theory, with the formula presented below 1 plus 1 over 1 factorial all the way up to 1 over 7 factorial. That will give us a number that will be represented in the y-axis in this graph as e. It is approximately 1.7, and like I said, I cannot give you the entire decimal places of it because it would be impossible. So why is this number important? Well, it is actually a very simple number, meaning that to calculate it, you only have to keep adding fractional numbers and you can actually get an asymptote with this value with the equation presented below, which will be 1 plus 1 over n to the power of n, or in algebraic terms, x. Why is this important? Well, because it is actually a transcendental number. Transcendental numbers are very interesting numbers because they are not able to be represented in algebra, just like imaginary numbers. But they actually are real numbers, meaning that, well, they have all the characteristics of a real number, although they cannot be treated as one. So that's why sometimes they are called complex numbers. So why you cannot calculate anything with them? Well, because since their decimal places are infinite, just like pi, you cannot write them down, only if you simplify them. And well, since they are infinite, you need to simplify them infinitely so that you can actually do something with them. We actually know pi as 3.1415 and sometimes 92, but pi has a lot of decimal places after it. So to express something with these numbers, you have to use a constant such as e, or pi, you use the pi Latin, Greek symbol. So why can they are not algebraic, and why can you do anything with them just to approximately calculate them? It's because, well, it is impossible to write them. So, for example, if you have an equation with a complex number such as e or pi, then you will need to add those to the final answer if you want to search for x. Why? Because, well, since they are irrational, there's no way you can simply add them or subtract them by clearing out x in the equation. So at the end you will have something like a complex equation, and then you will have x plus e or minus e or over e or pi, so you will have some complicated issues with them. Now, you use pi to calculate circles, but since pi can be really simplified, and we actually know a lot of decimals of pi, we use a very big simplification. Calculators use a really big simplification that can be stored in the database so that the error mistakes that will display when calculating something with pi are actually really, really small, but they do exist, meaning that you cannot calculate the perfect area of a circle in algebra because you will have a really, 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 really small mistake. So that's why they are very interesting in maths, because, well, you have some very complicated issues related with them. So this number was created by Leonard Euler, which actually was really interested with logarithms and with complex numbers such as pi. So that's why he calculated this number, which, as I said, serves as the asymptote of that particular function. So, and as we can see on the chart, we can keep adding and growing exponentially the value of n, which in the graph is displayed as 1, then 2, then 5, then 10, then 100, and so on. And we can see that the value of the value of y on the y-axis is actually really, really low, because it always stays at 2. Why? Because you cannot ever reach e or Euler's number with decimals, because you will need to have an infinite number of x values, meaning that it is actually an original number, but in theory, once you reach upon e, the graph will start at negative, infinite, and in the value of x. Why? Because it is actually a division of x, meaning that the graph is split into 2 and has an asymptote in x equals 0. That will be all for this video. Thanks for watching.